Hello and welcome. In this lecture, we're going to be adding in controller movement so that we can move around using a controller, which is what you're seeing going on right here. We're going to do this using a different set of axes for look up rate and look right rate, and we'll see why that is necessary. Let's dive in and find out why. So we want to be able to move around our scene using the controller. I can already do this when I am not in play mode. So we want to be able to do the same sort of movement as this with panning with the right stick and with moving around left and right with our left stick. And we can also go up and down, but that's not something that our pawn is going to be able to do because it's not a flying pawn. So what we're going to want to do is, first of all, it's easy to map the movement. What we have to do is go to our project settings, go down to wherever input is, engine input, and we've got our move forward axis. We've also got our move right axis, and that's pretty straightforward to add in yet another mapping as well as W and S. We can add in our gamepad. If we look under gamepad, you can see the left thumbstick. We want the Y-axis for moving forward. For the moving right, we're going to add the gamepad, and it's the gamepad, still the left stick, but this time we're doing X and Y axis, and we can see whether that is the right sort of movement. So go ahead and hit play. I use Alt-P as my shortcut for that. Then left and right works. Forward and backwards works, as we would expect. But obviously, turning doesn't work because we haven't mapped that yet. So let's give that a shot. If we go to Settings, Project Settings, and Input again, let's have a look. Look up, we're currently using the mouse Y. What would be wrong with just adding in here, for example, the gamepad, the right stick, and this time the Y axis? Well, on first attempt, we can go and have a little play. This might actually seem to be okay. So we go in and you can see we can move around. Yeah, sure, it's a little bit fast, but it's kind of okay, isn't it? Isn't that okay? Well, not really. And the reason ultimately boils down to frame rates and how these axes work. So what happens with a mouse when we're running a game at 30 frames per second, when we move our mouse from left to right across the screen at a kind of even speed, we might see that the axes values are something like 10, then 10, then 10. And this is telling us that each time the mouse has moved by 10 units to the right, and it's done it the same every frame. What happens if we double our frame rate? Well, suddenly the mouse is still moving at the same rate because the player is still moving their hand at the same speed. But because we're showing frames more often, we're having ticks more often, then what's going to happen is the input from the axes is actually going to be halved each time. We're going to get a 5, a 5, a 5, a 5, a 5. So great, that's fine, because that means that we're still going to be panning across our screen at the same rate, no matter whether we have a fast computer or a slow computer. If we move our mouse by a certain amount, you're going to notice the same amount of movement, which is what we want. Now, things change a little bit when we look at the controller. Say we go full throttle to the right with our analog controller, and it's at 30 frames per second. We get 1, then 1, then 1. Makes sense, right? What about if it's at 60 frames per second? We still get 1, then 1, then 1, then 1, but we get more of them because we're getting more frames. If you use that directly to affect the movement of your pawn, you're going to see that it moves at twice the speed at twice the frame rate, not what we want. So what we want to do is introduce some frame rate independence here. So to do this, we need to be able to multiply by the delta time. We kind of want to use the input axis to help us modulate the rotation speed. So that's a little bit to take in there, but what I mean is that we need to have something like a rotation rate variable. We're going to create a new U property for that, which is going to be an edit anywhere, and we are going to have it be a float, and it's going to be the rotation rate. Now, I'm going to use the same rotation rate for both up and left and right. You can go ahead and have a separate variable for both of those, and I don't really know what a good rotation rate is going to be here. I'm just going to give a flying guess here because I'm not sure what the units involved are here at all. So I'm just going to go ahead and say 10, but we'll see. Maybe that's way too fast, maybe that's way too slow. We can adjust that in our blueprint. So we can go ahead and save that. I'm going to go over to the C++, Alt-O to switch to the C++, by the way. And we're going to want to have a new type of axis so that we can distinguish between the move right, which is the mouse, a direct movement, versus the move right, or rather, sorry, the look right, which is the rate. So we're going to do that by going over to our project settings, and instead of having this gamepad left thumbstick mapped to the move right, sorry, not the left thumbstick, but the right one mapped to look up. I keep making that mistake. So remove that from that axis and add a new axis, which is going to be the look up rate. And this is going to take in our gamepad right. So gamepad right Y axis, because it's the look up, and we're saying that +1 should be the one that we're using. So then what we can do is we need to map this, and we don't want to map it directly to the add controller yaw because we need to do a little bit of maths to calculate the rates and make those rates frame rate independent. So what we're going to do is go over to Alt-O and create ourselves a lookup, which handily we've already got here, and I'm going to create it as lookup rate, and go ahead and create this Control-Shift-P, and I'm using my create implementation plugin to go ahead and do a lookup rate implementation. Got an axis value coming in, that's great. We then want to make sure that's what we're calling in setup player input component. So let's create a new line here, duplicate the look right. I'm going to call it lookup rate, like so, and then copy and paste the fully qualified reference to the function to call our lookup rate. Then essentially what we want to be calling at the end of the day is add controller input pitch, controller pitch input, but we want to multiply this by a couple of things. So our axis value comes in as a value between 0 and 1. If we multiply that, so axis value multiplied by the rate, rotation rate, then what we're going to get is a speed. But what we want is actually a distance. Like when we moved our mouse, we moved it a certain distance every frame. That's what was coming in. We want to convert this speed to distance. And if you remember some way back in some hazy maths class, to get from speed to distance, we need to multiply by the amount of time. So we do that by getting our delta seconds from the world. Now, what is delta seconds? That is the amount of time that it took for the last frame. So it's kind of the opposite of the frame rate. It's telling us how long a frame takes, which is great because that is the amount of time that we need to apply this movement over. So if you think about it, we've got a speed, we've got an amount of time that we need to apply that speed over. It gives us an amount of movement that we essentially want to apply to our controller pitch input. So that's what we want. Get world, first of all, because we want to get the level, or get the world around us, and then from that we use the arrow function to do get delta seconds, which tells us that we want to get the amount of time that elapsed in the last frame, which gives us again this approximation of our frame rate at the current moment in time. Now, you might be wondering why we're not doing the same with the movement input. And the reason is that the movement input, when you do an add input there, it's already supposing that that's a rate, not an actual amount of movement. So it's already doing this calculation for us, essentially under the hood. Let's save up the files, go over into Unreal and compile and see whether any of this is worth it. So let's head on into play. And I'm going to try and use my controller input. There we go. We're going up and down rather slowly, but hopefully this will be completely frame rate independent because we've used that delta time. So what I want you to do is to go ahead and implement the look right rate. So repeat the same method setup for looking right as you did for looking up, and tweak the speed so that it doesn't go really slow and you can actually use it to move around the level. Pause the video and have a go. Okay, welcome back. So first step was we went and created a new axis mapping in our project settings. We're going to have to do that again, this time for the look right rate, like so. What a mouthful. Then we're going to go and get the gamepad, the right this time, and the x-axis. That's what we're going to be mapping to. And then we're going to go over to our shooter header file this time. I'm going to duplicate the lookup rate. And let me just show you the files so you can see where I am over on the left-hand side. So we're going to have, instead of the lookup rate, it's going to be the look write rate, Control-Shift-P, create implementation. And we're going to have pretty much exactly the same code with the same multiplication that is getting us from, again, a speed to a amount of distance moved. That's the look write rate. So instead of doing the add controller pitch, we need to do the yaw input this time. And the look write rate is going to need to be called from our set player input component, or it needs to be called when the axis is actually being manipulated. So we're going to add another axis in here. Instead of lookup rate, it's going to be the look write rate. And then, so we're going to want to copy that reference to the function, remembering the ampersand before, and then the fully qualified A shooter character, : look write rate. Let's go ahead and save both that and the header file, go back into the project and exit play, which I left going, hit compile here, and then we should be able to dive in and have a play around. So up and down is working slowly, left and right, not quite working out how I would expect. Let's check our project settings. So our look write rate seems okay. Thumbstick right, thumbstick x-axis. Let's check that that's all going through into the C++ correctly. Bind axis look write rate. It's calling look write rate function. All seems in order, calling the yaw input as it should be. Don't know what happened there. I just hit recompile again and then hit play again. Sometimes you have to do this, but now the looking left and right is working, up and down is working, albeit at a very, very slow pace. So we're going to tweak around with our character blueprint. Let's go and find our BP shooter character, open up his blueprint, and then let's scroll on down and find the rotation rate, which I'm going to just multiply by 10, try and go 10 times faster, and then we'll find a value that makes sense somewhere in between. This is always one way that you can try and find values, is just by going and changing the order of magnitude first. Well, that's much more closely in the right ballpark. It's maybe a little too sensitive. So maybe I just slam that down by a half. Try about 50 this time, not 500, but 50. Let's try that out, hit play, and move my stick around. Okay, that's feeling much more natural. You might want to go somewhere just a little bit in between those two. So go in between the two again. I'll say about 70 this time, rather than going all the way to 100. 70 might be the right rate. Let's see if we've hit gold. Yes, I think so. I think 70 is going to be the right rate for me to move around. Obviously, this is the kind of thing that often games allow you to tweak, or allow the player to tweak in the settings. We're not going to look into that. That's beyond the scope of this section, but it is something that you might potentially want to expose to users in your own games. Cool, so in that lecture, we have seen the difference between controller input and mouse input, and how we have to deal with rates instead of absolute movements. So in the next lecture, we're going to look at that third-person camera that I kept hinting at. See you there.